Welcome, everybody. Thank you for taking the time out of your day to let us introduce and talk a little bit more about the Durlon LT100 advanced gasketing, specifically for low torque applications. So myself, sorry, technical difficulties already. A little bit of shameless promotion, which I did not put together myself. Thank you, Sil and Ria, for doing that. So I am Chett Norton. Obviously, I previously worked with Durabla, with TFC, and back over here now, the general manager. We're good? A little bit of sound there. Can everybody hear me okay?
Yes.
Okay, sorry, it's just froze. So obviously, paired with 20 years of sealing experience with the FSA, obviously a lot of application engineering, engineering manager type of scenarios. So some field-ready gasket insights, and again, some leak-free best practices from an industry leader. So that was myself. So thank you, Ria and Sylvia, for putting that together for me. You were too kind. So we have a little bit of an agenda here today, just to kind of keep us on task and give you, some brief overview points. We're going to talk about the product itself, the LT100. We're going to talk about its technical features and benefits. And then we're going to give you some industry applications where it may become useful for you to kind of go after that low-lying fruit. And at the end of it all, if I haven't done my job and anybody has some questions and answers, feel free to drop them in the chat. I do not see it currently right now, but Ria and Sil will keep me up to date. But we will have a session at the end for any question and answering period that's something that we didn't cover. Okay. So market need and development insight. With sealing in general, there are a lot of challenges in low torque environments, and there's several kind of constraints that can cause a lot of problems. Insufficient compression is probably one of the biggest ones, and why this gasket was kind of come fruit to tuition kind of scenario. With insufficient compression, low torque may not be enough force to compress the seal adequately, leading to leaks. That goes with flat flanges, bolting constraints, different types of scenarios. We have material selection. Obviously, inappropriate seal materials may not perform under well compression. And again, it's going to affect the durability and effectiveness of the gasket itself. Misalignment is another big one. Obviously, components may not align properly, causing uneven or different types of compression on the gasket that's not uniform, which can lead to potential failure. We have temperature variations. So changes in temperature can affect seal performance, especially if the material itself is not suited for the operating conditions. Vibration and flange movement. Now, this is another one too with some types of low torque type applications, pump connections, any type of FRP or anything where there's vibration, maybe a product is not, or piping is not well supported or robust. Again, these types of things can definitely affect the seal as well. Fluid compatibility, that's a big one. And obviously the seal must be compatible with the fluids or gases that they encounter. Low torque, might not be enough torque to prevent leaks in aggressive environments. And then lastly, we have aging and degradation. So obviously seals may degrade over time, particularly if they are elastomer based. These low torques may not allow for effective replacement or maintenance. So what we need to do is address these challenges often, and it involves careful design, material selection, and regular maintenance. So to give you a little bit of insight as well as why the LT100 was developed. Any question? Any hands up? Any thoughts? So really, we wanted to help users eliminate the most common sealing changes that we just described, right? Basically, a one and done gasket that users with the versatility to seal at low torque bolted flange joint assemblies, we call them BFGAAs, with some ease and definitely with confidence. We did have a couple design and engineering objectives when we wanted to do this and kind of put this project together. Obviously, we had some customer feedback. Versatility, again, one gasket for numerous applications. It reduces the incorrect gasket selection. And ease of installation, right? That's a big one as well, especially for all the pipe fitters and applications people that are doing the maintenance. Ease of installation is also a huge plus. So what is the Durlon LT100? Well, to start off, it is a peroxide cured EPDM carrier with a PTFE bonded gasket. So peroxide cured materials over, sulfur cured materials obviously give you a much better compression set. So a lot more rigid carrier or structure. Obviously, the PTFE insert itself gives you the chemical resistance to protect most of your applications. But this combination of PTFE and EPDM give this a very, very low seating stress requirement. Generally, we say a maximum of 1,000 PSI, ideally 500 PSI compression. Depending on the actual system operating temperature, you can get away with using the minimum seating stress. Now, this is much lower than a lot of compressed fiber materials, even some types of expanded PTFEs and whatnot. Okay. There is a dual rib design, as you can see here. That obviously decreases flange contact, which again is going to increase your gasket seating stress. And it does fit over a standard full face flange. As you can see here, the bowl holes, this is replicating a full face gasket, but can also be used in a raised flange scenario. There's a dual rib. I got ahead of myself already. So again, minimizing the seating stress. Obviously, there's certain points of contact. And again, that combination of EPDM and PTFE give you a very, very low seating stress. So we do have a proprietary manufacturing process. Obviously, these are made. We're not going to share that with you today, but again, it is something a little different that we just wanted to point out. So for those of you who have been on the Durlon website, maybe you got the email blast, that kind of thing. We do have, some technical literature. What you're seeing in your screen in front of you right now is the LT100 data sheet. There's a lot of very, very good information found on this sheet. Just to kind of go over a quick couple little areas that you would want to focus on. Obviously, there's the technical data sheet section where you have the physical properties. Obviously, it gives a color description, really not a big deal. We do use white EPDM. Some people, you can use black, you can use blue, purple, whatever. Obviously, white is generally, accepted in the industry for generally regarded as safe, food industry, stuff like that. There's no leachability or anything as such, so we wanted to use that color. Obviously, we have min and max temperatures that are going to be in there. That's very important when selecting the proper gasket. And obviously, maximum pressure, 250 PSI. For those using metric, we do have the bar there, which I believe is 17. Obviously hardness, obviously it is somewhat elastomer based, so it's going to seat at a lower gasket stress. It's only a 70 Duro Shore A. Again, so it's going to compress at a lot lower load. And we have MMY values there for people that are still using them for ASME design. Again, if you look at the Y value at 300 PSI, that's very, very low. So again, that's a very, minimum recommended seating stress. So again, at 300 PSI, it's probably one of the lowest ones you're going to get, which is really ideal for these low stress applications.
Hi, Chett. We have a question from the chat.
Yeah.
Yep. How flexible is the outer EPDM?
The outer EPDM itself is actually right around, like I said, right around the 70 itself. So you can see here, it is a little less rigid than the actual PTFE insert. If you can see this here, the carrier, obviously, I'd have to get you the hardness on the actual PTFE seal, but again, it's going to probably be around a 65, 70 Shore D, I believe. But again, it's fairly rigid. Like I said, you can bend it. You can see there, fairly rigid. So I hope that helps. Looking at also on this data sheet that you can see here, obviously there's a nice section on there that talks about the applications itself, acids, caustics, etc., and the industry served. So those are kind of the areas, the low-lying fruit that, you would, possibly actively pursue looking to use or to sell these gaskets to. On the back side of page 2, what you can see there is we do have a torque chart on there for the 1/2 inch to 24-inch 150 size. Obviously, it gives you minimums and maximums. Obviously, the minimum is, when this operating pressure is less than 250 PSI. The maximum torque is going to be based on 1,000 PSI gasket stress. Now, just to kind of extend and over accentuate some of these features, the one thing that I really want to talk about, obviously, the temperature range is pretty normal for an elastomeric based carrier with PTFE. You've got 300 Fahrenheit, 250 PSI, but high compression set is really important. And for those of you that don't know what compression set is, obviously it's basically the measure of how well material returns to its original shape after being compressed. Generally, they express this as a percentage, which indicates the amount of permanent deformation remaining. after that force is removed. So obviously a lower percentage is better. So if you had a gasket that had a compression set of 18 versus 35, obviously the 18% would be much more desirable. Again, listed the hardness again, that's important, having that soft, flexible outer carrier with the PTFE insert, and the Y value of 300. Again, it just really shows that how low of a stress that this gasket will seal at. So we do have some material advantages when using a gasket style as such, like this. So obviously there is a one-piece PTFE chemically bonded insert and using peroxide cured EPDM. So obviously that combination results in an excellent sealing at minimal bolt load. So again, having that PTFE one-piece insert, there would be no permeation or chemical to be able to get to the EPDM carrier ring. And then having PTFE, as you know, is almost chemically inert to almost anything, is going to give you the best chemical resistance and performance. Again, that one-piece shield is huge. It's not laminated together in two pieces. They're not, gluing them using a PSA type tape or anything as such. It is chemically bonded. So again, that one piece is really going to give you really good performance with that chemical resistance. And basically what it does is it eliminates a potential leak path and gives you that true 100% sealing integrity. So as far as design benefits are concerned, obviously that's what people really want to know is, how, why should I use it? Where would it give me?
Chett, sorry, I just have one quick question before you move on to design benefits. What is the advantage of the peroxide cured EPDM as opposed to regular EPDM?
So generally, there's two types of curing systems in EPDM. One is sulfur-based and the other is peroxide. Obviously, sulfur-based materials, like I said, the compression set is the main thing. It is generally a lot less. Sulfur-based curing systems are generally a little bit cheaper as well. But again, when it comes to actual compression set performance, peroxide cured is a much better selection. Does that help?
Sorry, yeah. So in other words, a peroxide cured EPDM will recover better than a sulfur-based EPDM?
Yes, the compression set would be better.
Okay, good.
Absolutely. So the nice thing about using this LT100 is obviously, it is designed for flat-faced flanges, but it is still compatible with raised face flanges. So obviously, a lot of people in a raised face flange will use a ring gasket. And here we have a full face in front of us. But again, it still has the same bolt holes. It will align. And a matter of fact, I know a lot of people like using a full face gasket in a ring setting, even though it's more material because it's easy for alignment, right? You're not trying to set that ring inside the flange and get it just right. So again, we can use that in traditional raised face flanges as well. Again, can't stress enough on the low bolt torque requirements. And, if you look at the actual torque chart that was on the second page of that technical data sheet, the values are very, very low. So, and again, in cases where you have those constraints in different materials, is something that just really stands out compared to other sealing materials. Again, FDA compliant construction, obviously using, a white-based EPDM that's peroxide cured, which is FDA compliant, and having a PTFE insert. All the points of contact are using FDA compliant material. Again, in a lot of those cases and applications as well, the bolting constraints might not be enough. They might be using stainless bolting or stuff that doesn't have the yield strength of a, say, a A193B7 stud. So again, using something with low bolt requirements would be a good application. And that's traditionally found in, plastic, non-metallic flanges. We see it in FRP as well. Even glass line pipe is another one where these vessels generally have really aggressive chemicals, but have very low torque requirements because they don't want to crack or fracture that glass lining in the pipe. So we can talk about a few of the industry applications and where you might find these types of gaskets or recommend using them. Obviously, in the food and beverage industry is pretty common. There's a lot of FDA compliance, a lot of pumps. Obviously a lot of pumps do have flat face mating surfaces, which would work well with a full face gasket. You do have applications that have a lot of different types of cleaning methods, that are high caustic, low caustic. So using the PTFE insert would be inert to any of that stuff. Pharmaceutical, again, FDA compliant materials. Again, a lot of pumps and stuff to move product. Having that chemical resistance is going to be huge. Water treatment plants is another one. Traditionally, a lot of non-metallic piping. There's aggressive chemicals. They use a lot of sodium hypochlorite like bleach, caustics and polymers for the wastewater treatment. Again, all those types of materials or chemicals are very aggressive towards just straight, maybe fiber-based gaskets or just pure rubber. So it would be a good application for that. And generally, a lot of those non-metallic piping type applications are very low bolt stress constraints. We have chemical processing, various piping materials. So depending on if it is CPVC, FRP, that type of stuff, a good application. Again, you're going to have some chemical aggression there. So that would be another good application for the PTFE insert. And again, FRP glass line piping in general. Again, generally in these cases, they're very low pressure. They're going to be, they have a lot of constraints to what those torques can be. And sometimes those values are hard to get from the manufacturer. But again, those constraints are generally the torques compared to a standard, spiral wound gasket or a fiber-based gasket are going to be more than half less. So in that case, it's a good application for something that has a very low seating stress. So from a compatible media standpoint, obviously we've got the three constraints here. Obviously you have acids. PTFE is good for aggressive chemicals that would normally attack standalone rubber materials by themselves, right? Gases themselves, obviously gases seem to be or tend to be a little bit trickier to seal than liquid. So having that one-piece insert does not allow any permeation through the actual middle of the gasket that could attack the carrier ring. And again, due to that low seating at a low stress. And then the pH. pH is something that, we see, when you have a range, we say it's 0 to 14, which is the full spectrum. But, there are applications, and I mentioned it a little bit earlier, particularly about CIP type cleaning in the food and beverage industries and stuff like that, where they will do a wash with something that is very acidic, and then they will come back and hit it with a very caustic material. So you see a very low aggressive pH on one side, and then they will bring it back the other way to make sure that they've, obviously cleaned the system well, obviously killed off any bacteria and et cetera. So that is an application where, paired up with, stainless bolts and whatnot, where a low stress gasket with resistance to wide range of pH and aggressive chemicals would be a very good fit. So sizings and standards right now, they are available in 1/2 inch to 24 inch in your standard B16, 21, 150 class gaskets. We have provided the flat face torque chart highlights that is on the back of the technical page 2. Obviously talking about the min and max torques again are going to be important because these materials will crush. You can't put a standard 4,800 PSI minimum gasket stress on them because of that EPDM carrier. So it is important to understand, what the actual seating stresses are going to be with the torque that you're applying. Now, I do want to point out, though, and I mentioned it earlier about the raised face flange compatibility. These can be used in raised face flanges, but again, generally your sealing area is much smaller. That raised face portion, is generally going to create 3 to 4 times more concentrated gasket stress than a standard full face just because of the size of the area of a full face versus a raised face ring gasket. So again, anytime we do not have torque charts for a raised face application, that is something that we would like you to reach out to so that we can ensure that you're applying ample load, but making sure that you're not crushing the material.
Chett, another question. Is
Certainly.
it also available in 300 class?
At this point, it is not. Generally, in most cases, the 300-pound class, it's a much more robust flange, and the bolting is a lot bigger, a lot beefier. You're handling a lot higher pressures. So this gasket itself is only rated to 250 PSI, which again, you're 285 at 150, and then it goes up from there. Impaired with the actual bolting material, it would be very crushable. at that point. Not to say that it couldn't be designed, but at this point, there's no plan to come out with a 300 in the short term. There are custom gasket applications that, TFC and GRI can come up with that would mimic something similar to this, whether it's an RCA gasket or something different. But at this point, I would say I wouldn't recommend them for 300-pound class for that. I would just probably use just a straight PTFE gasket like Durlon 9000. Okay, compliance and safety. Again, we keep pounding this home. Obviously, it's made from FDA compliant materials with that peroxide cured EPDM and PTFE. Notes and pressures, like we just talked about, again, maximum 250 PSI, 300 Fahrenheit. There are some constraints in that sense. Most of those types of, I won't call them ductile flanges, but CPVZ, FRP. Again, there are pressure and temperature constraints as well. So again, it kind of fits in that core niche type of application. Proper installation and use guidelines. Because you have a low seating stress gasket, that doesn't mean that you can't get away from proper installation, right? We still need to ensure that we are using procedures, whether it's, star tightening pattern with multiple tightening rounds, even though your torque values are much lower. For instance, if you were to give in a target of 100 foot-pounds with a fiber-based gasket, and maybe now we're using 30 instead, you still need multiple rounds of tightening to ensure that you're getting even compression, and you will still need a final tightening round with a possible retorque down the road. It's just good practice to ensure that you're giving that gasket the best opportunity to perform with even compression, okay? One that I always used to bang home with the gasket rig and doing the FADU training is lubrication is critical, particularly when the torque values that you will be using for a low stress type gasket as such will be much lower. So the factor for error is much more, minimal. You can't. So normally you use a torque value of 100 foot-pounds and, your K factor might be slightly skewed or you're not using lubrication. You lose 10-15% of that actual torque, which equates to lesser gasket stress. But in doing that, when we're only giving you, say, 30 foot-pounds, that's a big difference, and that could affect it. And again, it could go the opposite way where, the lubrication you're not taking into account, friction isn't robbing, and you might overcompress something like this. So again, lubrication is very important as always, and you need to make sure that you're using the proper K factors when doing torque values to ensure that you're not either overcompressing or not getting enough load on the gasket.
Sorry, Chett, one more question.
Certainly.
Is there another gasket you would recommend when the end user only has raised faced flanges?
There would have to be some consideration for, what is the media, what is the temperature. In a lot of cases, if we're talking less than class 300, PTFE type ring gaskets would be a good application. Depending on the performance of the pressure, maybe it's a Durtech with, PTFE or, a high performance graphite, or it really depends on the application. There are other types of gaskets out there, but are kind of more critical to depending on what your application actually is. You've got a lot of options. It's not just a one and you're kind of pigeonholed into one thing. With the Durlon portfolio of products, there are, numerous things depending on, what you have and what you're trying to seal and, what you're trying to achieve.
There was another question in the chat. Any distinct advantages versus the Asahi or Energizer styles?
Yeah, at this point too, there are some, obviously, our seating stresses with the proprietary, material facing that we're using paired with that carrier that we have selected. Again, seating stress is going to be very low. So that is something that is a huge advantage. Obviously, looking at material itself with obviously the spacing of the ribs, the type of profile, which we can't get into, the actual geometry. There are some differences there that we feel are a much better fit for performance. And again, having, when we talk about the advantages, I'll get to the next screen here. Obviously, from a positioning in the market, brand awareness, the Durlon brand is very, very aware out there, and I think in good graces with a lot of people. They're very cost effective, obviously, as well. Price and delivery for us is an advantage. With market studies that we've done, very, very competitive. So I think that would be a huge advantage to doing this. Obviously, we have stock of material now. You know, we've been plugging away at these for a while and tried to build our inventory up. You know, but now getting this out here, you know, we're hoping that that takes off, and you know, we'll have to keep at it and keep building them up. So there could be a little bit of a lag if everybody jumps on board and starts going gung ho, which we hope. But overall, you know, I think those are the key ones. You know, proprietary materials with a bit of tweaking and design configuration. You know, obviously the Durlon brand I think has a lot of merit, as it should. And you know, price and delivery is going to be a huge one.
Just one more question, and I do want to note as well, we do have a Q&A section coming up as well. So if anyone could save those for that, we can address those questions there as well. Is the Teflon inner ring similar to 9000 build material?
At this point, it is blue, and that is about the only similarity. At this point, it is not 9000 at this point, just due to the manufacturing process and how, you know, compression mold is sintering and these are made. That's slightly different. Not to say down the road that we could try and incorporate in that, but at this time, they are not similar. So availability and ordering, like I said, obviously, you know, for those who are distributors, you know, of GRI and TFC, they have stock and basically pricing. They can get that to you. So reach out to them for pricing, and hopefully, you know, you can make it work. So there are a few summary and key takeaways because we're almost 30 minutes in. I've kind of kept on track. I'm pretty proud of that. Something I just really want to hammer home is, you know, it's a versatile regulatory compliant sealing solution. You know, when I say versatile, you can use it in a lot of applications without carrying several different types of gaskets, right? Because the risk of, you know, using the wrong gasket for the wrong application is common, and it does happen. You know, you're getting high chemical resistance with mechanical integrity, right? So that's really important. But again, you know, the main thing here is it is designed for low torque sealing needs, which are very problematic, particularly with using certain fiber-based gaskets or even expanded PTFE, where you actually need quite a bit of load to get a seal. And in certain applications that is not ample or enough, then you need another solution, which would be something as this. So we do have, you know, obviously the website product page. As you can see here, there is a link down the link in the corner that you can't see, but it is found at the Durlon.com website under products, under Durlon LT100. You know, we have the product data sheet, which we've talked about. We have the webinar slide deck, which I believe this is going to be sent out later. It is being recorded, which hopefully will be helpful. And I believe that wraps it up. So if we want to open this up to questions, a Q&A, if anybody has, I do have a few standard stock questions just to jumpstart people in case anybody's afraid to ask. But if you want to open it up.
We do have one. Are these US manufactured?
No, they're not.
I have one.
Yeah, sure.
So I guess mainly because I'm not quite sure why people would choose a metal gasket over soft gaskets. But my question is this something that you would recommend in either application? Or does it only replace soft? Is it only for soft gasket application?
Well, I think because they are two different kind of classes of gaskets when you talk about semi-metallic and we'll call soft gaskets, you know, PTFE, fiber-based gaskets, etc., rubber. You know, depending on the constraints of the application. So you're not going to use a soft gasket in anything over class 300. But that being said, you can also use metallic gaskets in class 150, class 300, all the way up through to 15, 2500, if need be. This gasket itself is in a 150 class. So again, spiral wound gaskets, you know, corrugated flexible graphite, CFG style, Durtech, cam profiles can even be used in class 150 gaskets. Now those gaskets are generally flexible graphite based. So generally for higher temperature type of applications, where the max on something like this would be about 300 Fahrenheit and not several hundred. So again, you can get spiral wound gaskets with a PTFE winding. For aggressive chemicals, you'd have to pair up your metallurgy with the appropriate, you know, chemical resistance. But again, generally those seating stresses for those metallic gaskets in a 150 class for spiral wound are much higher. Generally, probably well above 5,000 PSI, even if they are low stress. Certain cam profile applications or dirt textiles have a much lower seating stress. So that might be very similar to something like this. But overall, I wouldn't say you could replace it if I understood the correction or the question correctly. But I think overall, in class 150, as long as you were under the 300 Fahrenheit, 250, you could replace a metallic gasket if they were using it in that application.
Thank you.
No problem.
That question. How about oxygen service, oxygen clean?
So at this point, we have not done any BAM or any type of low oxygen mechanical testing on this gasket. They could be cleaned for oxygen service. However, without the BAM test, I wouldn't recommend it at this time. Just because there is a lot of mechanical impact testing that needs to be vetted out, generally through Germany. At this point, it is not done. Not knowing 100%, I can't say to use it in an oxygen service at this time, Dirk.
Okay.
It's something that we can look at doing down the road if there's a lot of interest, but at this point, I would say no.
Okay.
Yep.
So that'll be something you could use straight 9,000 on and clean.
Pardon me?
I would think that then you could stay with 9,000, 9,002 clean.
Correct.
Oxygen gas. Okay.
Yes. Yeah, that is
One-
proven. They have done all the testing. The 9002 for oxygen service would probably be the best application for that.
Okay.
Yep.
What about low pressure steam?
Well, as long as the steam doesn't hit 300 Fahrenheit, so if you've got low pressure boilers for, maybe heating, stuff like that, it's possible. Again, you just have to be very leery of that max temperature, right, of 300 Fahrenheit. I don't have a steam chart in front of me, so I can't recall what pressure is 300 Fahrenheit. But again, it would be suitable, much similar to PTFE, except PTFE will go up to 500. But because of this EPDM carrier, you just want to watch that max temp.
Yeah, you're about 200 PSI.
Okay, thank you.
You got it, buddy.
There were two questions in the chat. The first one seems to be a price comparison question. So is there any information we have about prices on that at the moment?
I don't. Again, US market, Canadian market, world market are three different really animals. I know we've had sales in both, all three markets, or two anyways. And, under 12 inch, I know the pricing is really, really good. Other than that, I can't really give you pricing, because again, depending on if the person is buying direct from the end user, from a third party, you're best to get pricing from your distributor or from GRI if you are a distributor, and do a comparison for yourself, because I'm just not in touch with all those localized type markets.
And another question in the chat is, would this be a metal detectable gasket?
Pardon me?
Would this be a metal detectable gasket?
I'm not sure if I understand the question. I know there's no metal in the gasket itself. I know a lot of plants have metal detection, going down, particularly in the food industry. It wouldn't detect any metal, I don't believe, because there's nothing in it. So maybe that answers the question. There's no metal in the gasket itself. It shouldn't trigger off any metal. Obviously, just being PTFE and EPDM. All right. I've got a couple questions here just to kind of give, maybe just something along the torque lines. But again, what guidance should we provide customers who are used standard gaskets when recommending the LT100 for low torque applications? Obviously, the biggest thing that we want to talk about is, required torque requirements are much lower than what they're generally probably used to using. They may need to consider bolting materials to ensure that you're still achieving that 40 to 70% yield, that elastic kind of stretch. If you're under 40, you're not really getting that spring-like effect. And if you're, over that, you may start to elongate or yield the bolt. But again, and in certain cases, if they're using a A193B7 stud, it might be too much bolt for the application. They may need to go down to, a stainless bolt or a B8M class 2 or something along those lines to make sure they're in that elastic sweet spot while maintaining the recommended torque. And then also, what are the most common misapplications or installation errors that we may anticipate that we want to warn customers about? Obviously, the biggest one is, like I mentioned, is making sure that you use proper installation to make sure that you're achieving the recommended torques, because obviously the minimum and maximum seating stresses on this is ideally between 500 and 1000 psi, which is fairly easily achievable with your standard B7 bolts. So we just want to make sure that you're following the proper torque recommendations and not just using a hand wrench or something that you can't really calculate or understand what value you're applying, because there could be a possibility that you could crush the gasket. Again, these are low stress sealing gaskets. High loads are not their friend.
I think we're okay to wrap it up. And again, as a reminder to everybody, you can find the product on the Durlon website under the low seating gasket. I'll send the link in the chat again, just so that it's there for everybody. And yeah, thank you so much for attending.
Yeah, and I just want to say thanks to everybody for taking the time. 45 minutes out of your day. It's hard to get 45 minutes in my own day sometimes. So I can understand you taking the time out of your day to join. Obviously, my email's in the bottom of the screen. Everything is on the website. You can reach out to myself. I will put you in touch with the appropriate people. And again, if something comes up in the meantime where maybe you just were unsure, didn't want to ask, drop me a line or to the sales inbox, the TFC, the marketing box, and we'll definitely get you an answer. And again, thank you very much, and I hope everybody has a great week, and we'll talk to you soon.